Hello friends, we will study fracture mechanics in this video. Why do we study fracture mechanics? It provides quantitative treatment of fracture and it allows prediction of load that structures can withstand without failure. Initially, the scientists have predicted the theoretical failure load or theoretical fracture strength, that is also called theoretical cohesive strength. And based on the theoretical cohesive strength, they started using the material for applications, but they found that the material started failing at a stress value that is 10 to 1000 times lower than that of the theoretical cohesive strength value. So the experimental failure strength that was observed is 10 to 1000 times lower than that of the theoretical cohesive strength values. So the reason for the discrepancy between the two was the pre-existing flaws. The first one is dislocation that generally result in plastic deformation, and the second one is other defect like cracks, pores. Other defects are the genesis of fracture mechanics. Griffith explained the discrepancy and came up with a new fracture strength value based on the theory which he suggested that if there is a material under stress and there is a crack that is present in the material, this crack, if propagate, there are formation of two surfaces, and that surfaces will have surface energy associated, and no material wants to enhance the energy of the material. So Griffith suggested that the crack will propagate and produce new fracture surfaces only when the release of elastic strain energy will be more. If the release of elastic strain energy will be more, then the overall energy will be reduced of the material. So he suggested that a pre-existing crack would propagate only when the elastic strain energy released from the material exceed the energy required to form new fracture surfaces. And based on this theory, Griffith came up with the formula sigma f equal to 2e gamma by pi a to the power half. Here E is Young's modulus of the specimen, gamma is surface energy, gamma S surface energy per unit area of each fracture surface, A is half crack length, 2A is the crack length. It was found that this Griffith theory is only for brittle materials. However, the Griffith theory, when applied to metals which plastically deform, it was found that the theoretical fracture strength is found to be lower than that of the experimental value. Orowan then realized that for metals, the plastic work has to be included with the Griffith's equation. For that, he gave the equation as 2e gamma s plus gamma p upon pi a to the power half. He included the plastic work in the Griffith's equation, and by this addition, the experimental value and theoretical value finally came in agreement. Irwin then suggested that gamma p is difficult to measure, hence he replaced 2 multiplied by gamma s plus gamma p with g, and He gave the formula Eg by pi a to the power half. And here the G is strain energy release rate, that is the energy released per unit increase in crack length, or we can say crack extension force. We will see details of each theories in our upcoming videos. Hope you like the video. See you in next video. Goodbye. Enjoy your day.